Hello everyone. In last class we have discussed the basic of input-output transfer and asynchronous data transfer. Today I will discuss the mode of transfer. The data transfer can be handled in various modes. Some modes are used the CPU as an intermediate path, and other transfer that data directly and from the memory unit, and this can be handled by following three ways. The first two modes is program input output and interrupt driven input output modes used as an intermediate path with the help of CPU, and direct memory access transfer the data between the computer and external devices and memory units and external devices without supervision of the CPU. So in today's class we will discuss program input output and interrupt driven input output. So what is program input output mode? In this mode, data transfer that operations are the result in input output instruction, which is a part of a computer program. That means, as we know that a computer is executing the instruction one by one. When the CPU fetch the instruction register, an instruction register is an input output instruction. That means there will be a data transfer between the peripheral devices and computer memory. So in programmed input output mode, the instruction which is a part of a computer programs, each data transfer is initiated by an instruction which is a part of a program. Normally the data transfer is from CPU registers to peripheral devices. So normally the transfer happens between the CPU registers and peripheral devices and vice versa. So between the CPU registers and peripheral devices, or CPU register to peripheral devices and peripheral devices to CPU register. Once the data transfer is initiated, the CPU start monitoring the interface to see when the next transfer can be made. This is the most important part of the programmed input output mode. That is, during the data transfer, CPU continuously monitor the data transfer between the CPU registers and peripheral devices. The instruction of this program keep close tabs on everything the task take place, the interface unit and the input output device. So in program input output mode, the CPU is busy for monitoring the data transfer, and when the data transfer is occur, CPU can do nothing. So here is a waste of CPU times. This is a flowchart of program input output. Here you can see the CPU read issue command to the input output module. That means CPU instruct at this time, CPU fetch the instruction register and it take a input output instruction and it read issue command, CPU read issue command to the input output module. After that, the CPU check the status of the input output modules. That means the input output module check the current status to the CPU. Then CPU check whether the peripheral devices which are connected to the CPU ready or not. If the peripheral devices is ready, then read word from the input output module. That means CPU read that word from the input output module. This instruction has been sent to the input output module, and then write word into the memory. So here the data transfer happen from the input output module to memory via CPU. You can see here, if the input output device is not ready, then it is moved to here. That means the CPU have to check the status of input output module. When the data transfer is completed or data transfer is done, then the CPU check the program counter for the next instruction. As we know that the program counter store the address of the next instruction. If the data transfer is not completed, so or not successful, then CPU issue a read issue command to the input output module. So this is how the programmed IO is work. So what are the drawbacks of programmed IO? The main drawback of the program initiated IO was the CPU was monitor the units all the time when the program is executing. That means CPU is busy for monitor the program executing. The CPU stay in the program loop until the input output indicate it is ready for data transfer. The next one is, this is the time consuming process and the CPU time is wasted. That means, as we know that we use CPU for the executing, but here the CPU is wasting its time for checking whether the data transfer is completed or not. Lots of keeping eye on the execution of the program. Here the CPU wasting its time for keeping eye to the executing of the program. So how can I solve this problem? To remove this problem, an interrupt facility and special command can be used. This interrupt facility is added to this program input output, is nothing but a interrupt driven input output. So in this method, an interrupt facility and an interrupt command is used to inform the device about the start and the end of the transfer. So an interrupt facility and interrupt command is used to inform that the device about the start and end of the transfer. In the meantime, CPU executed other program. This is the main difference between the program IO and interrupt driven IO. In the previous case, programmed IO, CPU is busy for monitoring the entire program or data transfer. Here the CPU is busy to execute the other program. That means it is not monitoring the input output operations. When the interface determines that device is ready for data transfer, it generates an interrupt request. That means it is ready for data transfer and send it to the CPU or the computer. When the CPU receives the signals, it temporarily stops the executions. So after receiving the interrupt signal, then CPU stops the programs and branches to a service program to process the input output transfer as interrupt service subroutine. After completing, it is turned back to the task what it was originally performing. So here is the flow chart of interrupt driven input output. Here you can see it is the same as before we have discussed in program input output. Here CPU read issue command to the input output device and do something else. This is the new. So after read issue command, CPU is continuously executing the other instruction. That means here a context switching occurs. So when the peripheral device is ready for data transfer, that means it is ready to transfer, then the device make a interrupt to the CPU. Okay, this is the interrupt and read status of IO module, and CPU check the read status from the IO module. That means a status is sent from the IO to the CPU and along with an interrupt. Then the CPU check the status. If the status is ready, then is read word from the input output module. So CPU reads the work from the unflappable module and next store into the memory. This part is same as the previous. Here you can notice that there is no not ready signals. Why? Because when the peripheral device is ready, only then the device can send an interrupt signal. That means there is no need to not ready here. There is no need to not ready signals here. So this is how the interrupt driven works. So there are few drawbacks of interrupt driven also. The processor must suspend the work and later resume it. The second one is, if there are many devices, each can issue an interrupt and the processor must able to attend each of these based on some priority. So when we have more than one device and everyone is issue an interrupt, then the processor have to decide that based on the priority. And the third one, it is not very efficient technique, especially when the data we need to transfer in very large quantity. So it is not applicable for, it is not efficient for the large quantity data transfer, large amount of data transfer. The large amount of data transfer happen in DMA, that means direct memory access, which we will discuss in the next video. Thank you for watching this video. Thank you.